Python allows us to call a base class method inside a derived class method using the super function call. For example, when Python sees the expression super and init, Python will search the base classes for the init method and call it. Let's explore the super function in detail. Consider this example program. This contains the animal class, the dog class, and we call the dog constructor, and finally we call the jump method. Let's walk through this program step by step. Python first reads the animal and dog class definitions. Notice that the animal class is a base class of the dog class. The statement at line 14 tab 0 is Joe equals dog 47 bark. Python first calls the constructor, which is the init method of the dog class, or dog.init. The statement at line 9 tab 2 is super.initxy. This is a method call where the object is the super function call and the method name is init. As usual, LWPython first pushes the method call to the expression stack. Python then pushes the child expressions, which are the object and the method arguments. LWPython now evaluates super. Python first evaluates the function call arguments, but there aren't any, so an empty list is pushed to the expression stack. Super is a built-in function, so LWPython evaluates it in one step. From the control map entries, Python knows that it is currently inside the init method of the dog class. Also, Python knows that the first parameter of dog.init is self. And the value of self is Python reference 0. LWPython creates a Python super reference whose reference value is copied from self and class name is dog. Later, this information is used to find the init method in the base classes and pass the right reference to it. Python next evaluates the method arguments x and y. Python is now ready to evaluate the init method. The super reference class name is dog, so Python searches dog's base classes for the init method. The animal class contains the init method at line 2, so Python is going to jump there. Python constructs function input from the animal init method parameters and the top element of the value stack. Notice how Python converted Python super reference to Python reference 0. Python now jumped to the animal.init method. In lines 3 and 4, Python adds attributes x and y to the Python object at index 0. Python now jumps back to line 9. In line 10, Python adds the sound attribute to the same Python object. Python is now finished with the dog.init method. Python returns to line 14 and assigns the new Python reference to Joe. The new Python object has attributes x, y, and sound. X and y were added in the animal.init method, and sound was added in the dog.init method. Using the super call, the dog class was able to utilize the code in the animal class instead of duplicating it in the dog.init method. Now let's take a look at line 15, which is joe.jump. Python jumps inside the dog.jump method and assigns 5 to self.y. The statement at line 13 tab 2 is super.move. This is a method call where the object is the function call super and the method name is move. As before, Python first evaluates super. Python is now ready to evaluate the move method. The super reference class name is dog, so Python searches dog's base classes for the move method. The animal class contains the move method at line 5, so Python is going to jump there. The super reference is 0, so the first function input entry value is Python reference 0 as before. In line 6, Python increases self.x by 5. Python next returns to line 13, then finally to line 15. Interestingly, we were able to call the animal.move method inside the dog.jump method. Thus, the method names don't even have to be the same when invoking a base class method. Next, let's explore the super keyword properties. If at time t, the expression stack contains an empty stack followed by a stack with super and arguments, and local variables is LVS, the control map contains class and the class name at 0, and method name at 1, and the class map is CM, and CM at class name is class def, and class def at methods at method name is method def, and method def at params is the stack param name and other params, and LVS at param name is Python reference PI. Then at t+1, the empty stack and the super function call are popped from the expression stack, and the value stack contains Python super reference PI with class name. Later, after the method arguments have been evaluated, LWPython looks for method name in the base classes and jumps there. More precisely, if at time mu, the expression stack contains an empty stack followed by super.methodName with arguments, and value stack contains values, and the class map is CM, and the reverse of values is the stack with Python super reference PI with class name and args, and CM at class name equals class def, and class def at bases is base classes, and the result of searching for method name in base classes in class map CM is base method def, and base method def at params equals the stack base param and other base params. Then at time u+1, the function input is an empty map. Parameters is base param and other base params. And argument values is the stack with Python superreference PI with class name, and args. And at time u+2, the function input is the map with entry base param and Python reference PI. Parameters is other base params, and argument values is args. Once the function input has been constructed, LWPython retrieves the location of method name from the base method def and jumps there.